All right. So this is the second question. The seventh question, question 7. It says, what is the molarity of copper 2 chloride if 10.0 grams of copper chloride are dissolved in water to give 250.0 milliliter of solution? Now, I want us to analyze this question. So I have CuCl2 and I have the mass of it to be 10.0 gram. That is the mass. Now, dissolved in water to give, so it is dissolved in water. So it is dissolved in water. So solution is 250.0 milliliter. But molarity says that the volume must be in liter. So to get liter, we divide this by 1000. So this is the volume. So if I know this, you need to know that we are going to make use of mole and not mass. So to get the mole of this, we'll make use of this formula. I've told you, always make use of this formula whenever you're to find mass or whatever that has to do with mole or molar mass. But when it's volume and concentration, I'll still teach you the formula to use. So molar mass. So this is supposed to be mass. So mole is equals to mass over molar mass. So given mass is 10 gram. Molar mass of copper is given here, 134.5. They did as well. 134.5. 134.5. So if I do that, it will be 10 divided by 134.5. So that I have this to be 0.0743. Now, if I know that when I do 250 divided by 1000, I get this to be 0.25 liter. Now that I've gotten this, let's now plug this into our formula so that molarity. Always know that molarity is the same thing as concentration. When I'll be teaching you titration very soon, you'll understand that. So molarity is equals to now 0.0743 all over 0.25. So 0.0743 divided by 0.25. So this is going to give me 0.2972. Please punch your own. You see I'm rushing it. Punch your own so you'll be sure we are correct. And the unit for molarity, because of this is mole and this is liter. The unit is the same thing as that formula. So mole per liter. That's our final answer. Let's move to the 8th question. Number 8. Number 8 says, what is the molarity of sodium hydroxide? Okay, wait. Number 8 says, what is the molarity of sodium hydroxide solution? Molarity of sodium hydroxide solution. Shebi, that's where we are. What is the molarity of sodium hydroxide solution? Let me write it. NaOH. If the volume is 50.0 milliliter. And know that whenever you're doing anything in chemistry, always remember to convert this to liter. So divided by 1000, so that I can convert this to liter. Now, we are saying if 50.0 milliliter of the solution requires 38.6 milliliter of 0.0976 molarity or that is 76 concentration of HCl for titration. I want you to know that whenever you see this kind of question, notice that this is sodium hydroxide, alkaline. This is acid. So it will give us a neutralization reaction, which is sodium chloride plus water. You understand? So check if it's balanced. Sodium 1, 2 is balanced. Now, when it gives us this, now let's check. They said that this one, the molarity, okay, the volume of this particular one is 38.6 milliliter, but we need to convert it to liter divided by 1000. Now, if we convert this, notice that the volumes are known. We know the volumes. Then we know the concentration of this particular one. It is 0.0976. This is just like when you are doing your titration. And what is titration? Titration is simply a process of determining the concentration of an unknown solution using the concentration of a known solution. So acid-base titration is simply determining the concentration of acid or base using a known concentration. So anytime you're determining an unknown concentration using a known concentration, you're talking about titration. So since I know this, but I don't know this, let me put this to be like this. Boom, chakam, boom. So now notice something. Notice that in our titration, we normally use burettes for the known titrants. Then we use conical flasks for the titrant, or you call it analytes. So since we've done all these practicals, we understand this. Our problem here is to solve this question and be fast with it. In our practical class, we do practicals. But for the sake of this question, we need to now get to the point where I convert these volumes. 50 divided by 1000 will give me 0.05 liter, and 38.6 divided by 1000, I have 0.0386 liter. Now, if I know this, I need to now, the next thing is to check the ratio of sodium hydroxide to hydrogen chloride. So the ratio is simply 1:1. They are in the ratio of 1:1. They're in the ratio of 1:1. So anything that is 1:1, look at it. The stoichiometric ratio here, there's nothing here. There's nothing here, which means there's an invisible one. That means that anything that happens to this can as well happen to this. They are the same. Any answer you get, even if you do cross multiply this and whatever, it will be the same. Now, how do we now do this? The next part is to find the mole. If you remember, there is a formula for mole that I gave you, which says that mole is equals to concentration times volume. This concentration you see here is what molarity is all about. This is also molarity. Because when you make this concentration subject formula, it becomes that C is equals to N over V. Mole, amount in mole, all over volume. But for the fact that we know hydrogen chloride, let's find the mole. So making this subject of the formula, we now have that this is N equals to 0.0976 times 0.0386. So when you do the punching, I'm coming now. Ah, good. Everything I'm doing today is just dirty, please. Okay, so when you do this punching, the mole will be 0.0976 times 0.0386. We'll get the mole to be equals to 3.7674 times 10 raised to power minus 3. So if I know that, that means that the given mole here is something as 0.00367, okay, 4. So that means since they are in the same ratio, because even if I say, okay, I don't know this once more, if I make this x, cross multiply, x will be equals to 0.00376774. I'm carrying so much decimal points, with it, because the more decimal points you have, the more, or should I say, accurate your answer will be. So once I know this now, I've gotten my mole for this. So that is my mole. Now remember that mole is equals to CV, but I don't know the concentration of this sodium hydroxide. So concentration is equals to mole over volume. So that this becomes, the mole here is 0.0, should be 0.37674 divided by the volume given to us is 0.05. So when you punch this divided by 0.05, you have that this is the same as, the concentration is the same as saying 0.07534, which is approximately 0.075, even approximately 0.01. So this is our molarity. So concentration is determined using molarity. Concentration is another word for concentration is molarity. So this is our answer. This is our answer. Academic Daddy, please like, subscribe, share. All right, let's move to the ninth question. Let's move to the ninth question. The simplest is the ninth question. Let's move to the ninth question. All right, the ninth question says English is not our own. I have lithium carbonate contains 81% lithium and is used in the treatment of mental illness such as bipolar disorder. What mass of lithium is present in a 12.20 gram dose of lithium carbonate? Now there's something I want you to understand. There's something called mass percent. And mass percent is equals to mass fraction times 100. So if you know this, you need to know that mass fraction is simply mass of elements, or you say atomic mass, or you say molar mass of elements all over molar mass of compound, or total mass times 100. So everything here in this box is what we call mass fraction. So once you know this, anytime you see a question and that question is containing, and they tell you that question is 8.81% of an element lithium, it means that that is the mass percent. That's what it means. But if you see a question and you want to find the mass fraction, they tell you to find the mass fraction, all you simply need to do is to divide that percentage given to you by 100 so that you can get the mass fraction. So why am I saying this? Why I'm saying this is that they say what mass of lithium is present in a 12.20 gram dose of lithium carbonate. Anytime they ask you what mass of an element is in a compound, what mass of an element is in a compound, what mass of an element is in a compound, it simply means the mass fraction. Anytime they ask you what mass of an element is in a compound, it simply means just the mass fraction without having this times 100, just the mass fraction. Now if they tell you what mass of an element is in a compound and they give you a value, they tell you it's present in a 12.20 gram of a compound, that means that is going to be mass fraction times that value given. That's value, that's gram, that's gram of compound, that's gram of compound. So anytime they ask you what mass of an element is in a compound. That is, mass of an element in a compound. So the mass of an element in a compound is simply mass fraction times gram of that compound. So if that be the case, notice that this question gave us 8.81%. Be reading it. You can see, be seeing it. Now the question gave us 8.81%. So since it gave us 8.81%, this is mass percent, not mass fraction. To remove the percentage, we simply divide this by 100 so that the percentage will get out. So when you do 8.81 divided by 100, you have 0.0881. So this is the mass fraction. This is the mass fraction that they got actually. Then before timesing it by 100 to get the mass percentage. So the mass of an element in a compound is simply mass fraction times the gram of the compound. So they gave us 12.20 here. So simply do that mass fraction times 12.20 gram. So times 12.20 gram, so that you get 1.07482, approximately 1.07. So this is the mass of this element in this compound. So this is the sentence gram. Anything mass is gram. Please go on the yard, you tell them to come and subscribe. Help my life. As I'm helping your life, help my life. Tell your friends, even the ones that don't know what YouTube is, just tell them, go and subscribe. Finish. Thank you. So let's move to question 10. Okay, question 10 is empirical formula. It's the same thing with the first one we solved. It's almost the same thing with the first one we solved. Now question 2. Question 11 is what I will solve. So question 10, let it be a cracker for you if you don't know empirical formula by now. I believe I've solved it earlier. I've solved an empirical formula question. So this is your class work. So let's solve number 10 and number 11. So number 11. So number 11 says, what is the molarity of copper 2 chloride solution? We've solved something like this, just that they changed the figures. It says, what is the molarity of copper 2 chloride solution if 20 grams? So simply do 20 grams given divided by 134.5. That is to get the mole. So the mole here, to get the mole. So this is our mole. This is the mole. Now the volume of solution is 500 milliliter. So by 1000 to get the liter. So this is going to be 500 divided by 1000, so that I have 0.5 liter. So simply to get the molarity now, molarity is going to be mole over volume, which is the sentence saying 0.1487 divided by 0.5. So if you do this punchy, you have 0.2974, approximately 0.3. This thing is risky. Approximating is risky, but whichever way, you just know it. So mole over volume, which is mole over liter. So that's the answer to number 11. Thank you very much. Subscribe.